Hello, I am Brett Champion. I'm a developer on visualization features here at Wolfram. Today I'm going to give a quick look at what we've been working on recently, which amounts to a lot of small things and maybe one or two slightly bigger things. So I'm going to start with some changes to sort of basic graphics, not necessarily visualization specific, although they have some impact on plots and charts and that sort of thing. And then we'll look at some of the things that are specific to plots and charts and general visualization. So the first thing that I want to mention is that we are in the process of sort of overhauling the visual aesthetic of graphics in Mathematica. Perhaps currently the largest difference, which probably doesn't show up extremely well on the projector, is that the default font for graphics is changing from a serif font to a sans serif font, and we're also moving the axes and frames from straight black to just a really dark gray to sort of draw a bit more attention to your actual data, less attention to the axes and frames and ticks and labels and whatnot in the general case. Additionally, we have added a few color directives. So the image processing people were sort of the drive for adding support for more color spaces. So LAB colors, LUV, XYZ, which are all sort of international standards, were designed to be perceptually uniform in ways that RGB or hue are not. I was discussing this with somebody who knows way, way, way more than I do at lunch, and apparently even LAB isn't entirely perceptually uniform, especially at sort of small wavelengths. But it's still improvement over RGB in some ways. And the interesting thing about these is I think they're basically all based off of XYZ colors, which were 1931 or so, and those were, the parameters for that were sort of sampled by having lots of people look at colors and sort of doing statistical measurements rather than like RGB is 0 to 1 in red, and you get things where like green is this big huge swatch of color space and lots of greens all look the same, even as you vary the parameters. And so these color spaces sort of account for that a bit better than what your monitor, say, usually does. Also adding lots of primitives to the language. Most of these are coming about from the people working on regions. So here we have 3 of them. We have an orange half plane, which is going through 0, 0, and -1, 1 comma -1, and in the direction of 1, 1. And so we have that half plane. We have an infinite line that goes along one edge of the half plane, and then I'm drawing the sort of normal direction as a half line that goes from 0, 0 through 1, 1. The interesting thing about these is that they're infinite primitives, and so all of my coordinates that I've specified live in -1 to -1 in XY space. But if you look at it, the plot range here is set to 3, and so even though these are the 3 points that I'm using to specify all of these primitives, they're drawing well beyond that, and I can come over here and change 3 to 30. And for the most part, it will look exactly the same. So if I change it to 1/2, then it blows up. Just kidding. It still looks exactly the same, except now 2 of the points are off screen. And so this is useful for the region stuff. This is useful for creating demonstrations of basic geometry for middle school or high school. If you wanted to create Voronoi diagrams, you can now actually have the rays that go off to infinity on the outside edge. I've wanted this. I've wanted half-line for 13 years. So yes.
Can you define the half planes in terms of an inequality instead of by giving exemplar points?
Not as graphics primitives. I'm sure that the regions framework has things for going from some sort of symbolic region to, like, say, a half plane in that sense. So one of the big things that we're working on is geographics. Bjorn is going to be talking about this at 2:30, I believe, in this same room. So the basic idea is we can say that we want a polygon of Australia with some sort of relief map applied to it. And the syntax for this is nice and short, and you get a nice picture of Australia. Lots of interesting stuff being done behind the scenes to get this to work. And like I said, Bjorn will go into much, much more detail about this. So now we'll move on to sort of visualization, which, so plots and charts and this sort of thing. We are pushing out more data model support across the visualization functions. So time series and its older sibling temporal data time series is new in 10, temporal data was new in 9. In version 9, we had a little bit of support for temporal data. I think the list plot supported it. Slightly amusingly, dateless plot did not. That is taken care of now. Let's just make sure that's evaluated. So we can feed this into dateless plot. We can feed temporal data into bar chart. And in this case, it's throwing away the timestamps and working on the raw data. Same for histogram, so you can sort of see, what's the distribution of stock prices for Apple. You don't see it in a temporal sense, but as an overall sense of where they've been in the past year. You can see they've been, it's been a long time, a little bit below $450 a share. Yes?
Is that sort of weighted by the length of the interval?
No. It is very strictly, I have, timestamp value, as pairs, in the underlying data set. And it goes through and says timestamp by, and you end up with you just end up with a straight list of numbers, and it goes into histogram. Which brings us to weighted data. So weighted data is now supported through a lot of the visualization functions. So here we have 3 data sets. We have 1 to 99, not weighted at all. 1 to 99 weighted with itself, so 99 is really heavily weighted and 1 not so much. And then I'm using random choice to sample from my weighted data 1,000 elements, just as sort of a check of if I actually have data that's weighted according to this weighted data thing. In theory, the plot for weighted and the plot for sampled should look about the same. And so this was sort of our quick test of how things are looking. And so we look at the histogram. If you have the unweighted data, it's pretty much uniform. But for the weighted and the check sample, you get sort of linear progression of the weights within this. Likewise, for box whisker chart, you get skewed toward the high end of your range. And also for a smooth histogram, you get a shape that parallels the shape that we're seeing for the histograms up at the top. And does bar chart do anything with weighted data? Does it throw away the weights, or is it?
It completely on according to the PDF.
I better get rid of the sampled because that's. Okay, so it is basically throwing away the weights. Which I mean, I think is correct. So let's see. So we've continued to push legend development. So the legended wrapper is now supported across more of the visualization functions. So here's a parametric plot, and I've wrapped the first curve and the last curve in legended to give them specific labels without having to worry about everything else. And then that gets picked up and we get a label or a legend associated with that. We have more and improved automation. So if you have dashing or thickness as part of your curve styles, then the legend swatch or sample, this little prototype here, we extend that a bit so that for like a dashing specification, you have more chance to sort of detect what the pattern is so that you can identify it back into the curve.
Will you be able to change those 1 and 2 by something else, not by time?
Well, I mean, so these are just the placeholders that are generated by automatic. I mean, I can come in and change them to 1 and 2. Yeah, I mean, you set plot legends goes to a list of strings, and they could just get picked up. We're pushing legends out, or some of the automatic legends behavior out to vector plots and stream plots. We were a little bit conservative for version 9 in what we would do automatically in terms of generating the legend. Are you happy, Chris? Okay. Before the talk, Chris told me I needed to drop the mic, so let's. How did I have this on before? There we go. So here we have a vector plot with automatically generated legends. It's picking up the actual vector functions. It's picking up the sort of the appearance of the vectors, that arrow shape. If you change the vector style, it will pick up that and use that for the marker in the legend. All kinds of good stuff. We are starting to push units through to not just the data, but into other aspects of visualizations. So here we have a density plot, and we're going to say that our data is in meters, and our legend is labeled, correspondingly, that those values from -1 to 1 are labeled in meters, and that's just the normal, unit labeling mechanism of, gray text with a tooltip that I can see what the spelled out form of my unit is. So next we're going to look at a couple visualization functions that sort of started out life in alpha and they're moving back into Mathematica. The first one is number lines, which sort of is presenting itself as more useful than you might think. So there are a few basic forms of input for number lines. The first is you just give it a list of numbers, and it draws an axis and puts points, and perhaps useful for second graders or something. It will also work with intervals, including infinite intervals. So here I have an interval that goes from -10 out to -infinity, and then a couple of discrete intervals or finite intervals, and I've thrown a singleton point in at 0, and the infinite intervals are drawn with arrows, and hopefully it's fairly self-explanatory. Slightly more interesting is that you can give inequalities or predicates to number line plots in a variable. And in this case, I'm not even saying what the range of the variable is. And there's some magic code somewhere that I didn't write that figures out we're going to go from about -20 to 20 in this case. So this is the area where sine of x is less than cosine of x. And we have the little open markers indicating that those are not closed endpoints. If I change this to less than or equal to, then those fill in, because at those exact points, they are actually equal rather than less than. And so here's sort of an interesting example of combining number line plot with some other plot in a useful way. So we have a function, and we're going to plot this function in the normal sense, and we get a nice little cubic curve. And we're going to combine this with show with number line plot that's going to show us where the derivative is positive, where the derivative is negative, or where the derivative is 0. And using plot style, we're going to make one of them red, one of them blue, and at the stationary points, we're going to make them black. We have the legend that goes with this, and you can see sort of where you hit this inflection point, and then the slope decreases, slope is negative, and you hit the other inflection point, and it starts going up again. So this is one example of using number line plot in combination with other plots, and if you stay for Min's talk, you'll see even more. And so number line plot is just proving to be sort of really flexible and really useful. I think it's that it and the gauges are sort of starting to get into 1D visualization as opposed to 2D or 3D. And so that's sort of getting interesting. We're also adding Mandelbrot sets and Julia sets. So Mandelbrot set especially is sort of interesting in that it is, I think, the first built-in visualization function that works on complex numbers. And that sort of its syntax is in terms of complex numbers. So by default, we pick a region that covers most of the Mandelbrot set. But we can zoom in by giving a minimum, I suppose it's not strictly speaking a minimum and maximum, but 2 corners of a rectangle. And these are given as complex numbers. So here we're going from 0.2 to 0.4 plus 0.45i, and then we're going up a quarter unit in each direction. Additionally, so the plot is nice, but if you want to do sort of some other explorations, we're including a function which is currently called Mandelbrot set iteration count. We've had some ideas for some possibly better names, but it sort of depends on what we're able to do with the function. But basically, this will give you the underlying data for the iteration counts to escape the Mandelbrot set. And so then you can feed this into array plots, say, or you can feed it into contour plots, or do interesting sorts of analysis on things. And so this is I think mostly the same region as, no, it's not the same region. I guess it isn't. Yes?
I think it should be listable.
I think it should be listable. And it maybe, I just didn't try it. But no, I'm definitely in favor of this function being listable. Whether or not it's actually attribute listable, probably not. It'll probably be some form of pseudo listability where it's effectively listable, but so. And then there's Julia sets. And I wonder where that message came from. It must have been an example I was trying to get to. Actually, wait. Darn. Okay. Oh! The coloring still needs some work here. There are very small changes in the shade of blue, which I'm sure the people in the back can't see at all. The people in the front row perhaps have a chance. Okay. And then Julia set has corresponding iteration count type functions. Make some nice pictures. Not necessarily clear that it will combine well with other bits of functionality in Mathematica, but I believe this is sort of very common or very popular on Wolfram Alpha, and so they thought that it should come back into Mathematica itself. So, and then finally, we're in the process of adding plot themes. So some basic examples in case you weren't at my talk on Monday. So basically the idea behind plot themes is we hide all kinds of options behind one named option setting. So plot theme goes to business here is setting a different plot style, it's setting grid lines, it's turning on a frame and setting part of it to transparent, which is how we're getting sort of ticks on the left, or labels on the left-hand side, even though there's no axis that's actually there. The axis is there, it's just invisible. If you need to submit graphics to a publication that still requires black and white, monochrome will automatically do various stashing specifications. Detailed is sort of puts on a frame, puts in grid lines, automatically adds a legend. Sort of nice stuff, I think. But the idea behind plot themes is they sort of do a lot of work all at once. And related to this is, and going back to sort of my first point at the very beginning of the talk, is we're overhauling the overall appearance of graphics in Mathematica. And for some reason, table at small sizes likes to put lots of extra space in the rows. Actually, I bet if I change this to 3, maybe it will format the table better.
Are plot themes usually definable?
Yes, but not documented yet. The plan is for there to be a tutorial on how to define your own plot themes. At the moment, there's still a little bit of art to it. So here is the current suggestion for what plots and charts are going to look like by default in Mathematica 10. Still subject to change, but the overall idea is to bring all of them into a similar color palette, where before we have what you may or may not know is color data of 1 for plot and list plot, and then bar charts and pie charts we're using colors that aren't in color data at all, and are completely different, but sort of bringing everything into sort of the same spectrum of colors so that they fit together nicely.
Is there some global variable that contains a list of all the available plot themes?
There is, Again, undocumented, and in some ways possibly not as useful as you might think. I mean, to the extent that writing my talks, I evaluate the variable to see the list of themes, and there's out of the 100 or so themes that are listed in there, there's probably 20 at most that are actually things that I might want to consider using, as a talk, as a theme for the talk. And part of that is because the themes mechanism is sort of using itself. And so, like business is, a theme and it's setting 5 options, say. May actually be more than that. But the way that it's getting to this is through calling 4 or 5 smaller themes that are sort of component themes that it's built up out of. And so the global variable shows you, the big ones that are big comprehensive ones, as well as the ones that are just, 2 options that try to do some similar effects.
You factor themes
In a way. Well, I mean, it's not even factoring because, so there's not necessarily disjointness. You couldn't have themes that overlap, in which case we have a little weighting mechanism that says this theme wants this plot style, but it only wants it a little bit. Whereas this theme wants a plot style, and that's the whole purpose of that theme, and so it wants it a lot. So that we can, when we do combine these, that we have some way of sort of resolving them into a consistent result. So, and that concludes my talk. And if there are any other questions while I'm disconnecting my computer, and who's after me? Is that you, Min? Okay, so if
so there is a global variable in like the main plot themes?
I mean, there is.
If I wanted to make the same plot and all the different plot themes, I kind of get an idea of what's available.
I mean, there will be various mechanisms for exploring the plot themes, and either through the predictive interface or having some sort of wizard that will present you with what the ones that are going to have sort of the biggest payoff for you. And so hopefully you won't have to look through all 100 or whatever we end up with, because it takes a lot of time, and in a lot of cases, there may be the differences between some of them are slightly subtle, and it's just no fun looking through 100 options, especially if we can get it down to like a dozen that cover a wide range of use cases and are 95%, what you want 95% of the time. So, I mean, before you get to the full list of 100, I mean, you're probably better off starting with one theme and adding one additional option to tweak it in just the way that you want. So, thank you.